How's it going? Vasco here from the Angular University. Thank you for enrolling in my course. Let's get started. We are here at the official Typescript website. In this course we are going to build an application and we're going to use the work environment that you will typically find in your everyday programming life as a professional software developer. You will install Node on NPM and learn all the tools that you will need in a real project. But before diving into that, and we will do an extended introduction later, we are going to get a feeling immediately of what the TypeScript language feels like. For that, here in the official website of the TypeScript language, we have here a menu entry called Playground. If you click into that, you will see something like this. So this is an in-browser editor where you can try the language TypeScript on your left-hand side, and you can see the output in plain JavaScript on the right-hand side. The fact that their main editor is structured like this already gives us a hint of what is TypeScript and how should we use it. It's an improved version of JavaScript with, like its name says, type safety, and we're going to see already in this initial demo, what are the benefits of that. Let's say that we have a couple of variables here. We have the variable DC Comics and we have the variable Marvel. So as you can see, on the left hand side I have TypeScript and on the right hand side JavaScript, and they are exactly identical. So you could take a JavaScript program and pass it through the compiler of TypeScript and it would work without any modifications. You might have to set a couple of compiler flags for that to happen. We're going to cover that in this course. What I want you to take away from here is that it's an improved version of JavaScript and it compiles down to JavaScript. So let's say that these two variables that we have defined here, notice that they are in capital letters. We would probably want to make them constants. There is no way to declare a constant in plain JavaScript. But take a look here. If instead of making DC Comics a var, I declare it as a const, this is working. It's compiling down to a var on the right hand side. But here, if I try to modify DC Comics, and notice that the auto-completion is working out of the box. This is something that you don't have in plain JavaScript, or you have it in a limited way. This auto-completion has the same power of languages like Java, C-, etc. It just works, and it works all the time. And it's really helpful to build our program. So if we hit here DC Comics and we try to reassign it to something, take a look. Immediately we get here an error, and let's see the error. Left hand side of assignment cannot be a constant. So as you can see on the right hand side, we are still compiling down to plain JavaScript, and this would actually work if you would run it in the browser. But at compile time, we have detected an error right before we even run the code. This is one of the main advantages of TypeScript. Helpful messages that help us to write our program. Also the auto-completion. Let's see a little bit more. Let's create here a variable called editor, and we are going to assign it to DC Comics, again using auto-completion. Now we are going to add here an if statement, and we are going to add here implicitly a block using the curly braces. We are going to say that if the editor is equal to DC Comics, then we are going to do here something inside the block. We are going to define here a var, and we are going to call it Superman, and we are going to assign it to an object. So the object will have a name, which will be Superman, and it will have a property editor, which we are going to assign to editor as well. So notice here the repetition editor, editor, and notice that var is inside the block. So if we would log this out to the console and take a look, the standard APIs of the browser, like console, are available for auto-completion as well. This includes set timeout or any other standard browser API that you might think. You will have auto-completion working out of the box. So we are going to print out here to the screen hero inside the block, and we are going to add here a colon, and we are going to print out Superman. And notice Superman is available here for auto-completion, and take a look. in front of the word Superman, which is the name of the variable, we have something that looks like a type definition. But how can this be? We did not define any type in this program. Well, this type is inferred for us, and we're going to see what the consequences are. And now one would expect that because this variable is inside a block, we would expect that it's not visible here outside the block. But also notice we don't get any error, and Typescript will warn us if there is an error that the compiler is aware of. So this looks like valid code. Let's run it here using the run button. This will open a separate window. You will need to inspect the page and you will need to go here to the console of your DevTools. So what we have here two logging statements. One is hero inside the block, which is the Superman object. And we have here a second logging statement, hero outside the block, which is the same Superman object. So going back to our playground, we can see here that although this variable is defined inside a block, this is not a block scoped variable. It's also visible here. So this is one of the problems with plain JavaScript. There are no block scoped variables. The variables take the context of the function on which they are in. So in this case, how can TypeScript help us to catch this error? If instead of declaring Superman as a var, we declare it using the let keyword, we will now get here an error. Let's see what the error is. Cannot find name Superman. So declaring the variable with let instead of var made it a block scoped variable. And take a look. What does the code here look like? It's the same code as before. So the addition of let did not change anything into the generated JavaScript of our program, but we get a compile time error. This means that if in the browser we only run JavaScript that is the result of a valid compilation, we would not run into block scope issues. Let's see another thing that we have here. We have here Superman, and take a look. If I hover it, I have here the Superman definition, name and editor. What does this mean? If we try to the Superman variable to add here another property, let's say that the name of the property is creation date and we are going to assign it the value 1938. Take a look, we get here an error. Property creation date does not exist on type, and then we have the definition of the type with two variables only. So what happened here is, even though we did not use any annotation for defining the type of the Superman object, the compiler has inspected the program, has determined that this is an object with two properties, and it assumed that this object can only have those two properties and it cannot have other properties. So it implicitly created a type on the fly and assigned it to the Superman object. So now we get here an error. This might not be what we want. In typical JavaScript, we would be able to do this. We can always bypass the type checking by using any. And we're going to learn any in detail in a couple of lessons in the future. But this is just to say we can still write something that is very close to plain JavaScript if we really want to. But other than that, the type system is systematically helping us out to write our program. With this, we have an idea of the different features of the TypeScript language and how it helps us to write better programs. We have seen autocompletion in action, type inference, and those are some of the main features of the language. We're going to dive deep into many other features in the following sections. Right now, let's just give a quick high-level overview of the structure of the course and then straight into setting up your development environment. So without further ado, let's get started learning TypeScript.